Welcome to the deep dive.
Yeah,
Today, we're tackling SQL structured query language.
that's right.
Maybe you're bumping into this at work, or maybe you're just curious about, the tech that really drives a lot of the digital world.
It's everywhere, really.
Absolutely. So, whatever your reason, we're here to try and, cut through some of the jargon, give you a solid, hopefully engaging understanding of what SQL actually is.
And why it's important, yeah. Plus, maybe how you could even start, getting your hands dirty with it a bit.
Exactly. We've been looking through some material for this, specifically some excerpts from learningsql.txt.
Mm-hmm. We've tried to pull out the really key bits, the need to know stuff, hopefully presented in a way that actually sticks.
Okay, great. So let's start at the beginning then.
Right.
SQL. What exactly is it? I mean, what problem was it originally designed to solve?
Well, you got to picture the scene, right? It's the 1970s IBM. Businesses, even back then, were starting to pile up quite a bit of data. And the big challenge was, how do you actually ask that data questions? How do you get information out? Different computer systems had their own, often very specific, sometimes even secret ways of doing things.
Right, proprietary methods.
Exactly. And as the data volumes grew, these ad hoc methods just weren't efficient for getting insights or, generating reports. It was becoming a real bottleneck.
So like all this valuable information is locked up in different boxes, and each box needs a totally different key. Sounds frustrating.
Hugely inefficient, yeah. Initially the thinking was maybe centralize it all on big mainframes, let people connect via terminals.
Right.
But that didn't really fix the core problem. There was no common language to actually talk to the data, no matter where it was stored or how much of it there was.
And that's where SQL comes in.
That's exactly where SQL enters the picture. The whole point was to create a standard, a kind of universal language that ideally any database system could understand.
So you could use the same basic commands to get the info you needed wherever it was.
Precisely. Makes things much simpler.
Something interesting I saw in the source material, it draws a comparison to COBOL, that old programming language. What's the link there?
Yeah, that's a really insightful parallel. If you think back to, the late 1950s, COBOL was designed to be a programming language that could, in theory, run on different computers from different manufacturers.
Okay, cross-platform capability.
Right. SQL had a very similar goal, but focused specifically on accessing data. It wasn't about running whole programs, but about having that cross-system compatibility for querying databases.
Okay. So a standard way to ask questions no matter the database brand.
Exactly. It was a huge step forward for making data more accessible.
That makes total sense. A universal translator, but for data. Now, the source also mentions, though, that while the core concept is the same, SQL isn't just one single thing. There are different flavors.
Precisely. Yeah, that's a good way to put it. While the fundamental idea of asking structured questions remains, different database systems, different vendors have developed their own variations, often adding extra features or maybe tweaking the syntax a little.
Like dialects.
Kinda, yeah. The source specifically calls out four main types: Transact-SQL or T-SQL, which you mostly see with Microsoft SQL Server.
Okay.
Then there's PL/SQL, which is predominantly Oracle's version. And then two really big open source ones, MySQL, which is incredibly popular, and PostgreSQL, another very powerful, widely used open source database.
So T-SQL, PL/SQL, MySQL, PostgreSQL. Quite a few
Right.
options.
And the source makes a practical point too. Some of these, like MySQL and PostgreSQL, are free open source, which is fantastic for learning or maybe smaller projects.
Right. Lowers the barrier to entry.
Definitely.
Yeah.
While others, particularly the enterprise versions of Transact-SQL and PL/SQL, might involve licensing costs.
So the choice depends on the project, the budget, the specific features you need.
Absolutely. It boils down to your specific requirements.
Okay, so we have this standard language, SQL, but with these different dialects. If we were to sort of peek under the hood of a typical SQL system, and the source uses Transact-SQL as the example, what are the key parts we'd find?
Right, let's break it down. At the very heart of it all, you've got the database itself.
The main container.
Exactly. Think of it as the central organized repository for all your data, plus the structure that holds it all together. And this database, it could live on one big server, or it might be spread across several machines, depending on how big the whole operation is.
Okay, and inside that database, we have tables. The source uses a great analogy here. Super large spreadsheets.
It's a really helpful way to think about it, I think. Just like a spreadsheet, a table has rows and columns. Each column is set up to hold a specific kind of data. numbers, text, dates, things like that.
Standard spreadsheet stuff.
Pretty much. But where tables get really powerful in a database is how they can be joined together.
Linking them.
Exactly. This lets you store related bits of information very efficiently without repeating yourself everywhere. You might have customer details in one table, orders in another.
And you link them with, say, a customer ID.
Precisely. Then you can combine that information easily when you need to ask more complex questions that span across different types of data. Very efficient.
Makes sense?
Yeah.
Keep things tidy. Okay, so we have the database, the tables, then come the queries. These are the actual commands, right? The questions we ask.
That's it. Queries are the standard SQL commands you write to interact with the data in those tables. The source nicely groups them into the 4 basic actions.
Which are?
Create, for making new things like tables or other database objects. Read, which is select in SQL, just getting data out. This is probably what you do most often.
Looking things up.
Then update, for changing data that's already there. And delete, for removing data.
Create, read, update, delete. Sometimes called CRUD operations.
Exactly, CRUD. Those are the fundamentals of data manipulation using SQL.
Okay, got it. What's next on the list? Constraints. That sounds a bit restrictive.
Well, they are, but restrictive in a good way. Constraints are essentially rules you define to make sure the data in your tables stays accurate and consistent.
How so? Give me an example.
Okay, you might put a constraint on an email addresses column to ensure every single entry is unique, no duplicates.
Right.
Or a constraint on a field that's required, like maybe a last name, to prevent anyone from leaving it blank. Think about signing up for something online. You have to enter your email, right?
Yeah, it won't let you proceed otherwise.
That's basically a constraint in action at the database level. It's about enforcing data integrity, making sure the data is reliable, quality control.
Okay, that makes a lot more sense. Built-in quality checks. Now, what about stored procedures? The source mentions these sound like pre-saved queries.
That's a perfect way to describe them. A stored procedure is basically a set of SQL commands that you save inside the database itself and give a specific name. Then, instead of writing out all those commands every time, you can just call the procedure by its name, maybe passing in some specific information it needs, like a date range or a user ID.
And why would you do that? Performance.
That's a big reason, yeah. They can often be optimized by the database system for better performance. Plus, it means frequently used, maybe complex sequences of actions can be run really easily and consistently by users or even by other applications calling the database.
Like having a saved macro in your spreadsheet, but for database tasks.
Exactly. Very useful for common operations.
Cool. Then we have views, described as pseudo tables. What's the pseudo part about?
Right. A view is essentially a stored query. It doesn't hold data itself like a table does. Instead, it presents data. It might select specific columns, maybe from several joined tables, and often includes filters like where clauses in SQL to show only certain rows. So it looks and acts like a table when you query it, but it's actually a virtual representation based on the underlying real tables.
So it's like a saved custom lens to look at your data, showing just what you need from potentially complex underlying structures.
That's a great analogy. A custom lens. It simplifies things for users or applications that only need to see a specific slice of the data without them having to worry about the joins and filters every time.
Smart. Okay, with all this data, security must be massive. The source lists it as a component.
Oh, absolutely critical. SQL database systems have pretty sophisticated security features built in. You can control very precisely who gets to access what.
Like which tables someone can see.
Exactly. Which tables, which views, which stored procedures. You can grant specific permissions like read-only or update or delete permission to individual users or to groups of users.
Essential for protecting sensitive info.
Absolutely. And for maintaining data integrity too, preventing accidental or malicious changes.
And the last piece mentioned is transactions. Sounds important, especially if multiple things need to happen together correctly.
Yes, hugely important. A transaction is a way to group one or more SQL commands together, so they're treated as a single unit of work.
Okay, a single unit.
And the key principle is, it's all or nothing. Either all the commands within that transaction complete successfully, or if any one of them fails for any reason, maybe there's an error, maybe the system crashes midway, then the entire transaction is automatically rolled back. Any changes made by the successful commands within that transaction are undone.
So the database goes back to how it was before the transaction started.
Precisely. The system handles this rollback complexity for you. It ensures that your database remains in a consistent state, which is vital in systems where partial updates could cause chaos. Think banking, for example.
Yeah, you wouldn't want a transfer to take money out of one account but fail to put it into the other.
Exactly that scenario. Transactions prevent that kind of inconsistency.
Good to know that safety net is built in.
Ugh.
Okay, so SQL's been around since the 70s. That's quite a while in tech terms. The source asked the question directly, is the use of it dying out? What's the verdict?
Yeah, it's a fair question, but the clear answer, according to the source, and I think generally accepted, is no. Not even close, really.
Still going strong.
Very much so. SQL databases are still incredibly widely used. They're fundamental for managing data, for analyzing data. One huge advantage they have, especially over things like spreadsheets, is scalability.
Meaning they can handle way more data.
Exactly. When your data gets too big or too complex for a spreadsheet, which happens pretty quickly these days, SQL databases are built to handle those much larger volumes efficiently.
And what about skills? Is knowing SQL still valuable?
Hugely valuable. The source emphasizes that the demand for people with SQL skills in the job market remains very high. Data isn't going away, so the need to manage and query it isn't either.
Okay, so reports of SQL demise are greatly exaggerated, it seems. That leads to another interesting question the source brings up. Is SQL a real programming language? Where does it fit in?
The perennial debate. It definitely has its own specific syntax, its own vocabulary, just like C# or Python or Java. You have to learn the rules.
Right.
But its primary focus, its purpose, is really narrow compared to those general purpose languages. SQL is overwhelmingly about interacting with data in a database, getting it in, getting it out, changing it.
So you wouldn't write like a whole web application just using SQL?
No, absolutely not. You'd use another language for the application logic, the user interface, all that stuff. SQL is the tool that application uses to talk to the database part.
The source talks about SQL being declarative. What does that mean in practice?
It's a really key concept. Being declarative means when you write SQL, you tell the database what data you want. You describe the result you're looking for.
Like, give me all customers in California.
Exactly. You declare the what. You generally don't have to tell the database how to get which files to open, which indexes to use, the step-by-step procedure.
Okay, so it figures out the how itself.
Right. The database optimizer figures out the most efficient plan to retrieve the data you asked for. This is different from many imperative languages where you have to spell out the exact sequence of steps.
Interesting distinction.
And the source also makes a good point. For people who are already programmers in other languages, learning SQL is often a very natural and, frankly, necessary next step.
Because their applications need to talk to databases.
Almost always, yeah. If your application handles any significant amount of data, chances are it's interacting with a SQL database somewhere, so understanding SQL becomes really valuable.
Okay, so it's SQL powerful, very much alive, great for data, declarative. Now, for someone listening, maybe thinking, all right, I'm convinced maybe I should learn this. Where do they even start? It can seem intimidating.
It can, yeah, but the source actually gives some really practical starting points, which is helpful.
Like what?
Well, one obvious one these days is YouTube. Apparently, there's just a massive amount of tutorial content out there walking you through the basics.
Free videos, always good.
Absolutely. Another really practical suggestion is to download free versions of the actual SQL software.
Oh, even the big commercial ones offer free versions.
Often, yes. Things like SQL Server Developer Edition or Express Edition or Oracle's equivalent. They might have limitations, but they're usually more than enough for learning and personal projects, lets you get hands-on experience without spending anything.
That's huge. So cost isn't necessarily a barrier to just trying it out.
Not at all for getting started. What else? It mentions exploring SQL in the cloud.
Cloud databases.
Yeah, many cloud providers offer database services where you can spin up a SQL database pretty easily and just pay for what you use, sometimes with free tiers to start. It avoids having to install and manage the software on your own machine.
Convenient. Any other routes?
Well, the more traditional path. Just search online for SQL training course. The source says you'll be spoiled for choice, which I think is accurate. There are tons of online courses, boot camps, interactive platforms.
Covering all levels, presumably.
Yeah, from absolute beginner right up to advanced topics. And then, of course, there's the academic route college or university programs often cover databases and SQL as part of computer science or data science degrees.
All right. And one more.
One more. Yeah, for people already working, especially in tech or maybe data analysis roles, look for on-the-job opportunities. Can you shadow someone? Can you ask to help with a project that involves the database? Learning by doing in a real environment is often fantastic.
So it sounds like there really are quite a few pathways in, whether you like videos, hands-on software, structured courses, academic settings, or learning at work.
Exactly. There's likely a way to learn that fits your style and your situation. The main thing is just to, pick one and actually start experimenting.
All right, well, let's try and wrap up this deep dive. We've covered quite a bit of ground.
We have.
We looked at where SQL came from, that need in the 70s for a standard way to talk to growing data sets.
Right. Its origins at IBM and the problem it solved.
We talked about the different flavors like Transact-SQL, PL/SQL, MySQL, PostgreSQL.
The main variations.
And then we really broke down the components of a typical SQL system. Database itself, the tables inside it.
Queries to interact with the data, the CRUD operations.
Constraints for data integrity, stored procedures for reusable code, views for customized perspectives.
Security to control access, and transactions for that all-or-nothing safety.
We also tackled that question of whether SQL is dying out, spoiler. It's not.
Still very relevant, very much in demand.
And we touched on how it differs from general-purpose programming languages, being more declarative.
Focusing on the what, not the how.
And finally, we explored a whole bunch of practical ways anyone interested can actually start learning SQL.
Yeah, from YouTube to free software to online courses, lots of options.
So hopefully this has given you, our listener, a really solid foundation, a clearer picture of what SQL is all about and why it matters so much in today's data-driven world.
Absolutely. The goal was to demystify it a bit and show that it's both powerful and accessible.
Which brings us to our final thought, something for you to mull over. Considering the just incredible amounts of data being created constantly, what specific problems or interesting questions do you think having a good grasp of SQL could help you solve or explore? Maybe in your job, maybe in a hobby, maybe just out of curiosity.
Yeah, where could you apply this knowledge?
Give that some thought. And thanks for joining us for this deep dive.